Hey guys, this is Mrs. Oakstra. So I have the assignment that you guys had for last night done. So go ahead and take a look at your answers, compare them to mine. Pause the video so that you guys can check all of them. I don't have the graph up. I will show that to you guys tomorrow. I'm having problems with the computer and it won't let me get that. So go ahead and hit pause and check your answers. All right, so that's all of number 1. So then I also assigned for you guys to do number 4. So here's the number 4. Again, go ahead and hit pause, check your answers with mine. All right, so if you do have any questions, go ahead and ask me when I come back on Monday. If you guys would do me a great favor, flip back a few pages. Okay, flip back a few pages, because remember, we kind of jumped around yesterday. So we're going to jump back, and I want to go to where it says Mathematical Modeling Exercise 2. All right, Mathematical Modeling Exercise 2. This one has to do with business application. So yesterday, we talked only about the physics side of how quadratics get used, and today we're going to talk about the business applications. If you have a highlighter, you're going to need it. So again, if you need to hit pause and wait for everyone to get highlighters, or otherwise just underline. So a couple of the key terms that I want to make sure that we all get when we go through this section is that we need to understand what in the world they're talking about as they use different vocabulary. So quantity obviously is the number of items sold. Revenue, this is the amount of income based on sales. That's kind of nice to know. That will show up, okay, based on the sales. The unit cost or the production cost is the cost of producing the item, right? Because it's not free to make these things. And then profit. Profit is the amount of money that you get once you have sold this product, right? So it deducts, it takes off, it reduces the amount that it costs to take the item or to make the item versus the items that were sold. All right, so profit is this lovely little formula right down here. And we also have a couple other things where we're going to have to take the cost per item times the quantity of items sold, and our revenue is going to be the cost per unit and the quantity of items sold. All right, so those are the vocabs that we're going to be needing for our class today. All right, so let's take a look at this first problem. A theater decided to sell special event tickets at $10 per ticket to benefit a local charity. The theater can seat up to 1,000 people. All right, we can have 1,000 people in there. And the manager in the theater expects to sell all 1,000 seats for the event. To maximize the revenue for this event, the research company volunteered to do a survey to find out whether the price of the ticket could be increased without losing revenue. The results showed that for each $1 increase in ticket price, 20 fewer tickets were going to be sold. Okay, that's going to be important for us to know. So X says let X represent the number of $1 per ticket increase. Okay, so this is what X is. It's for every dollar increase. Write an expression to represent the expected price for each ticket. Now remember, they have to charge $10, right? It's $10 just to get this going, plus the $1 per ticket increase. Okay, so there is our expression that we can expect for our ticket price. Top of the next page, use the survey results to write an expression representing the possible number of tickets sold. Now remember, this place can seat 1,000 people. But every time we increase the price $1, we lose 20 people, right? 20 fewer people are going to buy them. Because, eventually the price gets too expensive. People are like, I'm not going to go. So we're going to subtract the 20 people for every time we increase the ticket $1. And you're like, well, why didn't you just, leave it at $10? Well, we're going to see if this actually is better to increase the price or not. So using X as the number of $1 ticket increases and the expression representing the price per ticket, write the function R to represent the total revenue. So our revenue is going to be R of X, the revenue of our tickets, is equal to the 10 plus the dollar increase, there's our price of our tickets, times how much we're actually going to have, how many seats we're going to have. We're going to have 1,000 minus 20 for every ticket increase. All right, so let's FOIL that out. Right, let's FOIL this whole thing out. 10 times 1,000, 10,000. And 10 times negative 20x is negative 200x. Then we have 1,000 times x, so 1,000x. And x times negative 20x is minus 20x squared. Well, let's clean this up and put it into standard form. So I'm going to have negative 20x squared out front. I can combine these and I get, what, 800x. And then let's put the 10,000 in the back. Now, as we know, standard form gives us some information, right? If we don't increase the price at all, they're going to make $10,000, right? So let's take this. And how many $1 ticket increases will produce the maximum revenue? Well, to find the maximum, we need to find the vertex. Find the vertex. Easiest way to do that is to take this equation and put it into vertex form. So let's take our equation and put it into vertex form. Right, we're going to just take this. I'm going to factor out a 20 out of the first two. Factor out a 20 out of those two. And so now I have, or excuse me, negative 20. And I'll factor and I'll have x squared minus 40x plus our box, right? Plus 10,000. And then plus whatever we have to fill in there. So what do we have to fill into our box? Let's take 40, cut it in half, and square it. So if I take 40, cut it in half, and square it, I have 400. But 400 times negative 20 gives me 8,000. I actually increased it by 8,000, right? This is 20 times 400. So let's put this into vertex form. Negative 20 times x minus 20, quantity squared, plus 18,000. So what is our vertex? 20 and 18,000. Okay, so we can increase the price. We can increase the price $20 and get the maximum profit, right? Our maximum profit is going to be $18,000. Right? So what should they charge for the ticket price? Well, go back to part A. Part A said it was 10 plus x. X is our number of increases, right? So 10 plus 20, we have $30. They should charge $30, and they're going to make $18,000 in profit, right? They'll make $18,000 in profit. So if we go across, how many tickets are we expecting them to sell, right? How many tickets are we expecting them to sell? Well, I'm going to take the 18,000 that they're going to make and divide it by the $30 per ticket, right? And they are going to sell 600 tickets. That's what we're expecting. Okay? Now, what if they had never increased the price, right? If they kept the price at just the $10, which was fine, right? You know you're going to sell every single seat at $10. They already are knowing this. So at the $10 ticket price, at the $10 price, they would make $10,000, right? Our y-intercept told us that. That was our starting point. But at $30, they make $18,000. So how much extra did they get? They got $8,000 extra. So it paid to actually bump up that price, right? Most people wouldn't think making the price go up would be better, but that's what happens in business. They figure out that optimum price that people are willing to pay. All right, jump over the problem we did yesterday. All right, jump over that problem, and we're going to go over to the next one, which was exercise 2, right? Amazing photography studio takes school pictures and charges $20 for each class picture, right? You've seen the ones in the hall where it's like the whole 8th grade class or whatever, right? The company sells an average of 12 class pictures in each classroom. They would like to have a special sale that will help them sell more pictures and actually increase their revenue. They hired a business analysis to determine how to do that. The analysis determined that for every reduction of $2, the cost in the class picture, there would be an additional 5 pictures sold per classroom. Of course, you can't get it down to where the price is free, but they can figure this out. All right, so we're going to have to write our function for this. So we're going to say that x is equal to the number of $2 reductions. That's what x is going to represent. How many reductions are we going to do? All right, so our production cost, or our profit, how much it's going to cost us, I should say, we're going to call that P of x. It's $20 for each class picture minus $2 for every reduction. Okay, and then let's do Q of x. Q of x is going to be the number of pictures sold. Well, it automatically sells 12 if we don't do the reduction. But if I do the reduction, I gain 5 pictures for every reduction that I do. So I'm going to take those two, multiply them to give me my new function. So the revenue is equal to our production minus 2x. Excuse me, that's our profit, our income, and now our production, and 12 plus 5x. All right, so let's FOIL that out. So I now have 240 plus 100x minus 24x minus 10x squared. All right, let's set this up into standard form. So negative 10x squared plus 76x plus 240. All right, what should, this is part B, what should the sale price be? Well, let's put it into vertex form, and we're going to figure out what our maximum price is going to be, or what our increments should be, I should say. So let's go through this. Let's take our function and put it into vertex form. Right, so I'm going to factor out a negative 10 out of the first 2 terms. So now I have x squared minus 7.6x plus our box, and then we have plus 240 plus our box. All right, what goes in our box? We're going to take half of 7.6 and we're going to square that. I don't know what it is. I don't have a calculator on me. I do know it's 3.8 quantity squared. This is going to be 3.8 quantity squared times 10. Okay, I'll get that in a minute once I grab my calculator. So if I rewrite this, I have negative 10 times x minus 3.8 squared, quantity squared, plus, and when I figure all this one out, I get 384.40. Remember, this is money, so I might as well put it all the way to the nearest penny. All right, so what kind of increments should I have? I am not going to increase this $3.80 every time. That's kind of a weird one. So I'm going to either increase this $3 or $4. $3 or $4 increments. Okay, so let's put 3 into our equation and see what we get. So if we put 3 in, I have negative 10 times 3 minus 3.8 quantity squared plus $384.40. So this actually becomes negative 10 times negative 0.8 quantity squared plus 384.40. And I end up getting $378. So if I charge or reduce it $3, I'm going to earn $378. What if I had done the $4 increment? What if I had done the $4 increment? So negative 10 times 4 minus 3.8 quantity squared plus 384.40. So now I have negative 10 times 0.2 quantity squared plus $384.40. And I get a grand total of $384. So how much how much will they make from the sale? Well, they're going to make $384. Right? They'll make $384 versus, if they didn't do it. So it's not like it's a huge difference for them. Okay? All right. So that's it for the lesson today, you guys. You guys are going to have your homework. You're going to do go over to the next page here. You guys are going to do number 2 about Katrina, developing an app. And you guys are going to do number 3, Edward drawing rectangles. Okay, so problems numbers 2 and 3 for your homework over the weekend. See you guys all on Monday.